Alright, this is question number 1 on the chemistry practice final. There will be 5 questions on the final. There are 10 on this practice final to give you some added practice. Okay, my name is Ramsey. And question number 1, write and balance the combustion of butane. Okay, but means 4, therefore butane would be C4H10. That comes from CnH2n plus 2, where N equals the number of carbons. So C4H10 plus O2 goes to CO2 plus H2O. Put my lines in the front. Okay, write my foot show. 4 carbons. I'm going to put a 4 here because there's really 1 carbon there. 10 hydrogens. I'm going to put a 5 here because 5 times 2 is 10. Now I have to count all the oxygens on this side. There is 4 times 2, which is 8 here, and 5 times 1, which is 5 here, and that's 13. Now because 13 is an odd number, I can either put 6.5 or 3 divided by 2 here, and it's balanced. B says, if a butane lighter is held under a glass containing 50 grams of water, initially at 25 degrees Celsius, rises to 31 degrees Celsius, if the specific heat of water is 4.184 joules to raise 1 gram by 1 degree Celsius, how much water energy was added? Energy is our key word. That tells us that we are going to be using E equals mc delta T. I'm going to list out my variables. M, 50 grams, and that's what I want, so I do not have to crisscross. C is the specific heat, which is 4.184 joules gram degree Celsius. Delta T is the change in temperature. It went from 25 to 31, so 31 degrees Celsius minus 25 degrees Celsius equals 6 degrees Celsius. I'm going to plug those into the equation. 50 grams multiplied by 4.184 joules gram degrees Celsius multiplied by 6 degrees Celsius. Change my pen here so you can see where the units cancel. The grams cancel, that's for sure. The degrees Celsius cancel, and we're left only with joules. So we're going to get some answer. It's going to be 50 times 4.1 times 6. So it's going to be around 1200. I'm not sure what that answer is going to be, but the unit on it's going to be joules. I don't have a calculator on me, so I'll let you do that math. But it's going to be around 1200. Use the factor below to crisscross your answer to kilojoules. So we have our answer above right here, whatever that is, and we want to convert it to kilojoules. So what you got on the bottom, what you want on the top, you got 1,000 joules from here for every 1 kilojoule. Joules cancel, and you're going to take your number, divide it by 1,000 in order to get kilojoules. Part D. Draw the products of the combustion of butane gas, or the products of the combustion of the butane gas are carbon dioxide and water. So I know that's CO2, and I know that that's H2O, both covalent compounds. Draw separate Lewis structures for CO2 and water. Okay, well, carbon has 4 dots, and oxygen has 6. Oxygen also has 6 here. I'm going to circle my pairs. I'm going to connect the dots. And there's CO2. And let's do water. connects. So there's water. Okay, so that's done. That's one. Give the shape name for carbon dioxide and water. So CO2, see there's linear geometry here. And for H2O, that's called bent. So we did that one. For 3, explain the difference in shape between CO2 and water. Okay, lone pairs, these right here, on the central atom in H2O push bonds into bent position. Alright, let's move on to the next one. Question number 1. Write and balance the combustion of methane gas. Okay, methane is C1H4 plus O2 goes to CO2 plus H2O. Put my lines in the front. Put my show. 1 carbon, 1 carbon. So we're going 1 and 1. That's good. 4 hydrogens, 2 hydrogens. We're going 2. Count all the O's here. So 2 O's here, because 1 times 2. 2 O's here equals 4. Even number. I can just simply put a 2 there and I'm good to go. This question again is asking us for how much energy. So we're going to use our MC delta T equation. Let's list everything out. M is 100 grams. C, water again. Very common to use water as the tool to calculate how much energy is absorbed from a chemical reaction. And delta T, well, it goes from 22 to 100. So 100 minus 22 is equal to 78 degrees Celsius. So we're going to plug those into our equation. 100 grams, 4.184 joules gram degrees Celsius, 78 degrees Celsius. I'm going to switch pens so we can see the units again. Grams cancel, degrees Celsius cancel, and we'll end up with joules once again. So you're going to multiply 100 by 4 by 78. So you're going to get 400 multiplied by, it's going to be a fairly large number in that case. I can't do that one in my head, but the answer is going to be something joules. Again, you're going to multiply 100 by 4.184 times 78. Going to crisscross our answer from above here, 2 kilojoules. What you got on the bottom, what you want on the top. Joules has the 1000 next to it. 1 kilojoule. Good to go. This one says methane and O2, these are the reactants. They want me to draw the separate Lewis structures. Methane is a really easy one because there are 4 lonely dots on carbon and 1 lonely dot on hydrogen. So they go perfect. There's CH4. Oxygen is a Twinkie. So those are just going to connect nice and pretty to make a little double bond. Looks like that. Give the shape name for methane. Methane has 4 things attached, so it's called a tetrahedral. And 3, explain the shape, why it's symmetrical. So there are no lone pairs. Bonds stretch out to get far away from one another. We used to call this the separate valence shell electron pair repulsion. I'll see you guys in the next video. Take care.